Hello, this is another intake video for the series for the Cadillac 472-500, and today we're going to talk about the boogeyman intake. Now, this intake was originally designed by Potter Automotive out of Tennessee. When I first contacted him, he was making sheet metal intakes, and this is in the 90s. He was making sheet metal intakes for the Cadillac to do dual quad. And I got a hold of him, and he wanted like $2,200 for an intake, which was a lot. I mean, this is the 90s. But he told me at the time he was tired of making them, and he was working on making a cast version so that he could quit having to hand make intakes. And so at one point he sent me drawings, and it was not exactly this intake. The drawing I got was narrower. The center was only as wide as the four barrels on a Holly carburetor, and the runners were a little bit longer. And that looked pretty acceptable. And he got to the point where he was ready to start casting them, and he was a little short on money to actually make the casting happen. So he asked a bunch of us to prepay for intakes in order to get the casting done. I bought these two at that time and two tops. He was making tops so that it was dual quad. And this is a bolt-on top for the intake. And I got two tops and two intakes at the time. And I prepaid him so that he had cash to go get them made. And it wasn't just me, some other guys did it too, so he had enough money to actually make this intake happen. Now, when he got done and he shipped them to me, this is the intake I got. And I was immediately aghast. I mean, the intake, this is how it came, and this Plenum is just huge. It's monstrous. And I called him up and asked him what he was thinking and why it wasn't at the drawings, and he had some trouble getting the runner geometry right and whatnot, and that's what caused this to be a little bit wider. But I told him, I said the Plenum volume is too big. We're going to have trouble. I mean, even then, I knew that big Plenum really dampens the signal to the carburetor. So that means the carburetor does not behave itself well at all. And this Plenum is just huge. And at the time, when I was talking to him on the phone, I was like, basically, the only thing this is good for is a supercharger. And he asked me what I meant, because he really wasn't a blower or boost sort of guy. Richard was a all-out, naturally aspirated guy. He wanted as much horsepower as he could get out of a naturally aspirated motor. That was his goal in life. He didn't do power adders. So I explained to him that with the way that the intake is made, that all he'd have to do is send one of these to BDS, and they'd make a top that fit like a 671 or 871, and they could probably piece together a drive, and he could start selling, blower kits, or BDS could, and he could sell them intakes. I said it's at least going to be good for that, because it's a lot like regular blower intakes that you see for other motors, especially since I had this bolt-on top, so you can just make a plate. And that's how the BDS blower kit happened. Is Richard made this kit, and a simple comment, and he called them up, and they were more than happy to make a blower kit at that point, because the intake is the hard part. And so our blower intakes were born that way. Now, Richard really didn't mean this to be a blower intake. That was not his thing. his thing was carburetors. He meant this. He made tops. He meant it to be dual quad. I mean, that's what he wanted to do. Now, a lot of guys tried to run this and had trouble. And even Richard had trouble with the Plenum. And people started trying to fill him with putty. And Richard, if you ever look at one of his EMC motors, the Engine Masters Challenge, he actually used this intake with an even taller top on it. But what he did was he actually cast in putty a single plane intake inside of this giant Plenum. So it wasn't this big open space. You know, it had a big tall thing, a single carburetor in the middle, and he kind of made foam inserts and then just filled the whole rest of it with like Valspar. And so that's how he was using this intake. And as we went over the years, people tried various things with this intake. They tried extending the runners. I mean, this has a really short runner. So big plenum and short runner, that means this thing is way high RPM. Basically higher than most Cadillacs will get to in order to really make use of it. And we went on years, and some people did okay, and then went on some street rods. A lot of them over the years got sold to BDS and became blower kits, and you could even buy one of these from Richard at the time. He called it the boogeyman intake. It's written right on the end of the intake. Now, you could buy one of these, make up a plate. I thought about putting like a little 250 mini blower. You know, I talked about the 174 that I had pretty good luck with. Well, years ago, the 250 was used a lot in marine applications on like big block Chevys. So they were pretty easy to get. And I debated putting 250, just make up my own plate, and put a 250 supercharger on top of this and use it myself as a supercharger intake. And so I never really ran them a lot. Years went on. And it got kind of a bad reputation for not working well. And like I said, some street rod guys would run it and suffer through its poor performance for the look, for the dual quad look. Some guys tried to fill them in, and there's been all sorts of things. So once Cadillac Performance Parts, which is the name of Richard Potter's business, when it went out of business, CAD Company bought up everything from them. He basically bought the company out. And one of the things he got, of course, was the mold for this intake. And he kept making them. I mean, he did, if any of you guys watch all the Richard Holdner videos, at one point I even point out that he had a whole pallet of these just cast up. I mean, so there was a whole big run of them. And most of them, like I said, were getting sold for like superchargers. That's why you see more and more supercharger kit pictures and guys running, you know, an 871 because BDS had easy access to the intake and they were just CNCing a top and putting the kit together, and there you go, you got a supercharger. And that works really well. But CAD Company wanted to try and see if we could make this work better in its original intended purpose. Now, years had gone on, and I kept thinking about what I could do to improve this as I learned more and more about intake manifolds. And I was with him in that I wanted to be able to run multiple carburetors. In fact, most of you all know that one of the tops I made was a 12-pack, 3 500 CFM Edelbrock carburetors. And I had done that shortly after I got this intake, just because I kind of noticed that they fit well on the length of the intake. And that was the neat thing about this intake, is that it had a fairly long uh, plate length on it. So all sorts of things will fit on this carburetor. You just have to make a different top, and the next thing you can run, 3 little 4 barrels. You could run, a 6 pack, 3 500 Hollies maybe, or 3 or 4 Rochester 2 jets, or 2 quadrujets, or whatever. I mean, it really was kind of versatile in that you could run all sorts of other interesting carburetor combinations. The problem is it didn't run well. And if you got up in RPM, it started doing okay. And that's the same as we talk about with other things, is it's about airspeed. And so it took RPM or a big motor. I mean, if you started building one of the really big cubic inch motors and you tried to get some more airflow through it, it started trying to behave itself. And Richard kept trying too back when he had it. But Cadco was, can we sort this out? Courtney really wanted to see if we could make this work. And part of that was, even if we wind up down the road having to change the mold a little bit to maybe the original design so that it worked better, that was okay with him too. It's just, let's see if we can make a better intake out of what he was having made and out of the investment. Making a mold for an intake is a lot of money. And I'm sure CAD Company paid a piece of change in order to buy that mold and all the stuff, because he bought all the stuff from them, in order to buy out the company and still have it exist. And he needs to sell a fair amount of intakes in order to recover some of the money he's got into trying to make it work. Now, when I was talking to him, he just sold, a handful a year, and a lot of them were strictly to BDS. So I told him I had a few ideas because I had been thinking about it for lots of years. And I wanted my 12-pack to run. People used to ask me, because I had pictures of that, well, how'd that run? Well, that doesn't run. That's never going to run, and I had not run it on anything, partly because I wasn't real sure how the intake was going to do. Now, years ago, even before Cadco came along asking about the intake, one of the things I did was I cut one of mine down. And they all come this height, this big plenum. But I knew I had to lose some of this plenum space in order to get the intake to respond better. And so one of the things I did is cut it all the way down to where I was just on top of the runner. And that would reduce the plenum space inside the intake. Now, Richard, even though this plenum was big, and I don't quite understand why, when he cast these tops, he actually even added more plenum space. And I've never quite understood why that was, unless it was to reduce the machining needed by just having an edge. But it was a real problem. So we went on to testing a bunch of ideas on trying to make this work. And one of my main ideas was this divider. And this is not really my idea. I'm a big Offenhauser intake fan. I feel like some of his intakes are, at the time, truly state of the art and well thought about. I think he really had good ideas, and the world kind of went beyond and on from what they were doing in the way of intakes. Now, on all these intake videos I've been doing, we've been talking about airspeed. And that's kind of where I learned more about airspeed, is because that was really Offenhauser's big push. That was one of the things at the time. You got to remember, he was way back. I mean, he started with like flathead motors, and we didn't understand a lot about intakes back then, but he really started getting a good understanding of that. And even when we started going to other V8s, he made some interesting intakes. Now, one of the intakes he made was a dual quad intake that I always loved the looks of. And he made them for dual Hollies, and he made them for dual quadrajets. That's where we got the idea for the quadrajets. He made all sorts of, and each intake was individual. He actually cast it as a whole thing, but he had interchangeable mold parts in order to be able to make the same intake, but with different carburetor flanges. So one of the things he did to make it work was added a divider down the center to reduce the plenum by half. And that increases the airspeed because this half of the intake is only drawing on this half of the car. So in some ways, it's kind of like a dual plane intake, but it's called a 180. The reason is on a dual plane, remember, it's kind of trying to follow the firing order of the sequence so that you're drawing on this side, then this side, then this side, then this side. Well, by just splitting down the middle, you're not exactly doing that. You can have one cylinder fire fairly close to another one, and that can kind of rob Peter to pay Paul in the way of fuel distribution. And that was really one of the things that we fought on the dyno, was trying to get the fuel distribution correct. Now, this isn't the only thing we tried. We did inserts, we extended the runners, we reduced the plenum, we tried to just fill up the plenum space, we tried the tall one, we tried the short one, we tried extending the runner up here. We tried a lot of things. Any idea that we had, we tried to see how it would do. Now, the interesting thing, which isn't completely unexpected, is this shorter one with less plenum space actually behaved itself better than the taller one. And that's not unexpected. Like I said, plenum is a big dampener. Now, if you run an itty-bitty carburetor, you want some plenum space because that'll give it time to try and refill. But if you run a couple of big carburetors on this, or even a couple of medium-sized carburetors, let's say, you wind up with really sluggish air and really poor metering at low RPM, and it doesn't clear up until you really get going. So on this one, this simple spacer actually worked very well by cutting down the intake and adding a divider in, which is a simple fix. Like I said, we did all sorts of complicated things in order to try and get it to work. And some of them worked pretty well. But amazingly enough, the Offenhauser simple divider actually worked the best. Now, this is still a log style intake. They used to make intakes back in the day with a big tube and just a couple of short runners in and put a carburetor in the middle for, straight 4s and straight 6s and whatnot. And those were log style intakes. This is basically still this. You have this long plenum and short runner. Now, no matter what you do, this runner is technically too short. This thing is tuned to way high RPM. So we're fighting that. Now, as cast, these runners, when I put them on the flow bench, flowed 245 CFM. And so that's a fair amount. And actually, you can get more out of them. the end of this runner is cast in the stock size of the stock intake port. And you could enlarge that a little bit, especially since this is a very short straight runner, and you could get that CFM to come up some. So if you're going to port heads, maybe raise the intake up a little bit, raise the port up a little bit, you can get a little more CFM out of them that will be appropriate for a cast iron ported head. Now, you'd still probably want to do this divider because that's not enough CFM to really make this work without the divider. The other thing you got to realize is because this is a log style, it doesn't have very good fuel distribution. And because it's 180, which was one of the complaints people had about some of the ones from Offenhauser, especially if you put a single carb in the middle of it, is you wind up with some distribution ills. And that's a problem. It won't run well. When we first put this on the motor that we tested on, it would not even load in on the dyno in order to run. I mean, we couldn't even get it to stabilize enough at lower RPM because it was just so bad. It really showed on the basic intake with a basic top, and we even tried a single carburetor top that Cadco company had on hand, and it did not do well. I mean, we just couldn't get it to behave itself. And that's when we started trying to fill the plenum because I knew the plenum was a problem. And we got it a little bit better, but it was still a problem. Eventually, we got it to where it would load in better and actually run more like a motor's supposed to run. Now, like I said, the little spacers and making the runner longer did help, but you're only talking a little bit longer. I mean, we're talking maybe an inch. And this is one of the things that I kind of laugh at, especially if you watch a lot of porting videos. I mean, they talk about, a longer runner. Well, they're sometimes talking, a tenth of an inch longer or 2/10 of an inch longer. That's nothing. To really start changing the RPM, I mean, you got to be talking inches. And this little runner is only like 2.5 inches long. Even by adding another inch to the inside of it, it's still only 3.5 inches long. It is a short runner. You compare that to like an Edelbrock that has an 8-inch long runner, and you start seeing that, you literally can't put a long enough runner in this intake to make the power band tune on the runner to be right. So what I looked at was more a fix. Now, as we start talking about airflow and airspeed, not everything is about airflow. Now, don't disregard airflow, because airflow is really about the horsepower you're going to make. The more airflow you can get, the more total amount of air you can get into the motor, is really more about the horsepower you are going to make. But for a lot of us, especially when we're talking street vehicles, it's about the airflow below that peak. And that's really all about airspeed. And that peak torque is really about airspeed. Now, even horsepower is technically about airspeed. Though the total flow matters, the motor will peak. Peak torque happens at like 240 feet per second, and peak horsepower will happen at like 320 feet per second. And that's a certain calculation. Now remember, all this stuff, there's mathematics to do all this stuff, but we're not getting into that. I'm not trying to teach you the math of intakes or the math of how engines work. We're talking about understanding generally enough that you can make good decisions about what to do, like this divider. Now, knowing that the intake had a problem, and I'm kind of stuck with what the intake is, my goal was to increase the airspeed because this was so sluggish at low RPM because the airspeed was so poor that the only thing I could think of was if I divided it and reduced the amount of carburetor that it could see and cut the plenum not only down, but then in half. So I'm running maybe a third of the plenum that this runner's going to see. The airspeed goes way up. And that really worked. This simple divider worked amazingly well. Now we got really close on some of the inserts that we did to what the simple divider is, but you're talking about complicated to super simple. Plus, I want you to understand there's a lot of these intakes already out there in the world. So if you pick one up, you need to kind of know, well, what can I do simply to make it work better? And this divider really does that. And we'll go over the numbers here in a minute. Now, this divider comes all the way up to the carburetor itself. So when you have the plate on, it literally, I actually did another little plate here to sit on top of that one. It literally uses only half of the carburetor. And that's kind of just like a dual plane on the, especially the factory one where it's isolated, is suddenly if you've got two, you know, we'll even say two 700s on here, two Holley 700s, that's 1400 CFM. Well, suddenly that runner draw is only seeing 700 CFM, and it's got less plenum to pull from, so the signal's way better, and it ran way better. It was noticeably. You know, we started having really good load in on the dyno, and we did all this. When we look at this, and if you're already looking at the board, you know, we started out by testing a baseline motor with the Edelbrock intake. Now, the baseline motor was 10-to-1, 240 cam, Edelbrock intake, and a 950 carb. And so it was a fairly hot motor. But remember, this is kind of a big intake, so I didn't want to put it on necessarily a stocker motor. That would certainly aggravate problems that we may not have seen a solution because the motor wasn't really big enough. I can always try this if I get the make it run motor. I might try this on a basic stocker motor and see if it behaves itself at all with my modification on the street. Because the next question becomes, if it's a smaller motor and on the street, not on the dyno at wide open throttle, will it still behave itself? So anyway, to carry on, the divider part really works. And you can run multiple carburetors, but do not run a single carburetor. I tried it, even with the divider plate, even with the filler plates. The single carburetor has a really bad tendency to dump the fuel down the four center runners, and the outside ones are lean. So you wind up with these that are way rich and these that are way lean. And it just doesn't run well. It really needs the fuel coming in of a dual quad where you've got the fuel coming in on top of each pair of runners. Now, technically, you could probably, if you've got two carbs, you could probably even put another divider in across here, which was one thought I had if we had trouble. But this ran well enough that I wouldn't really worry about it at this point. And remember, with my 12-pack, I was running three 500 CFM Edelbrocks. And that's a cool looking intake, and it ran really well. Now, part of the thing about this intake is still airspeed. And I know I'm saying airspeed, airspeed, airspeed. But that's really what we have to keep thinking about, especially when we're trying to fix problems where it doesn't run well. You put two regular double pumpers on this, and it's not going to do as well as even, you know, if you put two 750s on here and three 500s on here, you have basically about the same CFM. But the Edelbrock carburetors have an air control valve on it, just like the Quadrajet does. And if you don't really need the airflow, it doesn't tip open. And one of the advantages of that design and why it's used with GM is that keeps the airspeed up. By not tipping in until you really need it, then that airspeed keeps going, especially when you first get on it. You don't have that whole carburetor. If you're having an airspeed problem and you have two 750s on here and you just dump them open, the vacuum drops to nothing, the air tries to stall, and the motor may even, bellyache or just stop because the air can't keep moving. And that's one of the advantages of some of the carbs you might want to put on this. That's part of the reason I chose Edelbrock carburetors for this particular application. That, and they were shorter, so they fit. And like I said, one of the benefits, this is a phenolic board. Now, this turned out to be a little fragile, but it let me make it really fast. Phenolic is basically impregnated wood fiber, and so it's kind of resin and fiber. But you can literally drill on this and do it just like wood. So it's not hard like aluminum in order to make a top. Not that making a flat top even out of aluminum would be that complicated. But this went on okay. I had a little trouble getting it to seal because it does have some flex in it. But that's one thing to think about if you have this intake and you don't have a lot of skills on making stuff. The phenolic did work. It just took a little took a little RTV and a little fussing around, a little careful to make sure it's sealed. Plus, I had to give up a bolt hole because I didn't have room for it with the car. But you could run all sorts of different combinations, and for a decent street rod motor, bigger motor, that's not a bad thing. I mean, you could do all sorts of interesting carburation. And I've seen some of these intakes. One showed real promise that had like 8 little throttle bodies on it. And so that was, it unfortunately got set aside because the guy's entire life was destroyed by a tornado. Intake survived, but he had other things that were more pressing. So we never really got to see how well it ran, but it seemed like an old promise. But he had done a bunch of stuff in the Plenum to try and fix it, extending the runners and whatnot. And like I said, this simple divider that's an Offenhauser idea actually worked amazingly well. Now, one of the things that we've thought about trying to do with this is make it into a fuel injection intake. Fuel injection, you can get away with more Plenum. If you look at, now they're usually longer runner, but if you look at factory intakes, they usually have a pretty good Plenum space. This intake has a bigger boss here, so you could put in injectors, and that kind of solves, or should solve, I haven't run it, but should solve the distribution issues that this intake has. And so if you put an injector at each runner, probably even the divider, I was kind of looking at maybe if I took a LT1 throttle body that had 2 throttle bodies and could maybe kind of mount it, here I'll try and hold it up there, maybe mount it right on the end. Actually thinking about going out the back rather than the front so that it would fit Eldorado. This is lower profile, and if we could get this in the front and get it to run halfway decent, it might be a viable alternative to run more horsepower on the Eldorado and keep it underneath the hood. That's one of the thinkings that we haven't gotten around to testing. I mean, there's lots of stuff going on. So that was one thought about this intake. Now, I'm going to talk about this board a little bit because I want you to understand what we saw on the dyno. Now, initially, the Edelbrock was 502 foot-pounds at 2100 RPM. That was where we were starting our test. That's as low as we could go on the dyno. I'll also tell you that's lower than most dynos can go. The Cadco dyno has some alterations, so it does better at low RPM load in because these motors tend to be so low RPM. You can't really test. I mean, you might on an inertia dyno be able to get a little bit lower and see, but you really can't test that off idle on the dyno easy, just because of how things work. So at that load in point, which was 2100 RPM, the Edelbrock had 502 foot-pounds of torque. Now, when you got up on the motor, that foot-pound peaked at 3900 RPM with 606 foot-pounds. And that's a typical combination for CAD company. You know, this is one of his bigger cams, and that's really trying to make better use of the Edelbrock. You could probably get a little bit more horsepower out of it, though probably not too much more torque. If you start modifying the Edelbrock a little bit, go to, like I've talked about, a Dominator carburetor, you know, maybe a little bigger cam, you can start nudging that horsepower up a little, or that horsepower up a little bit, but the torque's going to probably stay right around that 600 or just under. And it made 502 horsepower at 5100 RPM. And like I said, we chose a motor that he was used to, that was one of his kind of standard combinations of a decent output motor. I mean, it's 10-to-1. It's got, like I said, a 240 cam. That was a 950 carb. Like I said before, if you really start running the Edelbrock, it takes a bigger carb. And it ran really well. I mean, that was a good combination. And we did that on purpose. He knew that was good, and that was a baseline, and that really let us see where we were doing with this intake and with our modifications. Now, the next line over here is the bigger intake with the extended runners and the filled and shortened plenum and 2 quadrajets. Now, like I just talked about, the quadrajets were a good choice on this carb because of how they control air. They have those little primaries, your initial hit has pretty high speed, and then you get into the bigger secondaries. Plus, I'm going to tell you, it sounded really good. The quadrajet's got a unique sound, and in stereo, it's even better. And I have those videos of some of these runs on my personal YouTube channel, so it should be at the top of the page with where there's a link to other people's channels. One of those should have my name on it too, and that takes you to my personal page, and I posted some videos of this particular intake being run on the dyno so you can see it. Now, with the filler and trying to make it run, that foot-pound of torque at tip end dropped down to 424 foot-pounds. Now that just goes to show you how much trouble we were having, because that was one of the better runs with it filled. Before that, we were having a terrible time. But that's a drop. I mean, we were at 502 with the Edelbrock and down to 424 foot-pounds at that super low RPM where we started. So that's a pretty big drop in torque, which makes sense because you still have the whole carburetor feeding the whole plenum, and you still have a fairly short runner. So technically this whole assembly is really still set up for higher RPM. So as it got going, it got up to 585 foot-pounds at 4,400. And that's on the board too, if you can read it, hopefully. That is just down a little bit. Remember, we were at 606 at 3,900. So, like I said, the intake that shows you, the intake is actually tuned for a little higher RPM because our RPM came up. And Of course, we've got a little more airflow, which helps higher RPM. And we did have filler. We were trying to get the airspeed up. We did have a little longer runner, but like I said, we're still only talking like 3.5. We might have been close to 4 inches, but it was not a long runner. But that's only down at that point by like 15 foot-pounds. So that's actually not doing too bad. If you had run a little bit of gear, a little bit of converter, and that fill in, that would have worked okay. Um, so that was one possibility. The interesting thing, and it again, it shows you about the intake. Remember, we have more airflow. It's tuned to higher RPM. It's got a common plenum, so it's drawing off of all the carb, both carbs. You know, remember, 2 quadrujets. It went up to 510 horsepower. So there's that little bit of gain in horsepower that I'm talking about on how it's tuned. Now, granted, that isn't enough to worry about. I mean, I'm very fond of saying, you know, if you're not gaining 20, 30, don't even talk to me. Because those little bits of horsepower, especially out on the street, you're not going to really hardly notice. But that also shows you that once it got running, it was actually starting to run pretty well. So, I mean, you might have been able to run that combination with either as-cast boogeyman head and a little bigger cam, try and get the airflow up, and more stall converter and a little more gear, and that could be a really hot setup with 2 quadrujets, and you'd have enough air to feed it. And that was with, like I said, basically just reducing the plenum size, reducing it to what the original drawing was, just as wide as the carburetor, and trying to get as much extra runner in there. And we just used hardwood filler in order to try and test it. I wasn't trying to make an intake that would last forever, but if it worked, Cadco was willing to modify a mold in order to cast them that way so that they would work. Now, the reason we didn't jump on that is because then we started testing this, and I tested and I don't have the dyno sheet. We did a lot of dyno runs, and I don't have every dyno sheet. And for this video, I wasn't going to run down to Cadco and see if I could dredge it up off the computer. There was a lot of dyno runs. I mean, we spent days and days trying to run this motor. So anyway, we started running this one, and we did it with dual quads, but the one I have listed here is actually my 12 pack. But that's very similar. I mean, they ran virtually identical to the quadrujet. And this simple divider and this simple cut down, at that tip in, if you look way over here, at that tip in, it had 514 foot-pounds of torque. Now, that's actually up from what the Edelbrock had. So we're talking about an intake that is suddenly making more torque at bottom end than a dual plane Edelbrock. And that says a lot about how it was working. The little air valve, control valve, which increases the airspeed through the side, plus the divider, plus the cut down to remove plenum, got the airspeed up to where this really worked. It was truly amazing. I mean, it wanted to take off. You go to that tip in, and we actually had to load it a little harder because the motor just wanted to go. And that was compared to an Edelbrock, which is a dual plane. An Edelbrock dual plane that was making 606 foot-pounds of torque at peak, and yet here we're making more torque at 2100 than it was. And part of that is because what I told you before on the Edelbrock is that little squiggle and the plenum design doesn't always help it behave. And you can wind up with funny things. And this being a little straighter shot and a little more straightforward and fuel coming in right on top of the runners made it work a little bit better. And this is a little lower angle, so it's coming in at the head at a little lower angle. Now, these are standard Cadco heads. They're not raised port, they're not raised runner, they're not fixing the bump. All they are is bigger valve, some bowl work, a little bit of work right at the pinch point, and call it good to get the most out of the basic CFM that you can get out of it without just spending days porting on it. And so that probably flows. I haven't had one on the bench, but that probably flows somewhere around 280, 290 CFM. And like I said, this intake flowed like 245 as cast, and that's how we were running it. So I could have probably even gotten a little more out of it if I'd raised the runner on the intake and raised the runner on the head a little bit, but that wasn't what I was trying to do. And my point is that at that tip in, I was making lots of torque. This ran really good. This is really simple, So as you got up in RPM, I actually didn't do as well. The Edelbrock made 606 foot-pounds at its peak, and that was at 3,900. The 12-pack peaked at 577 and a half at 4,200. But like I've just said about the Quadrajet running, remember, this intake is a lot shorter runner. This runner is only like 2.5. The Edelbrock is like 8. And so that has an effect on how the torque will peak because it changes some of the airspeed. So we were bound to lose a little bit. But when we're only talking like 30 foot-pounds of torque at peak, and we've moved peak RPM up a little bit, that's really not too bad. Again, if you were probably going to run this as opposed to a more basic motor where you're not upping the gear, an Eldorado that you can't change the gear in, though you'd have to do something because the Edelbrock won't fit under the hood, or some other car, even a sedan DeVille where you might have room for the Edelbrock, but you'd have to basically change the rear end to get more gear in it. Well, this would be more high end because it is still really meant to be higher speed. But that's a respectable enough number that you could actually run it and probably not be too unhappy about how it goes. And like I said, I am going to, once I get the Monty running, which is still off a bit, I am going to do some drivability testing with this intake on basically a stock motor. And I want to do it on basically a stock motor for a reason, because that'll really point out if there's a problem. If I can get it to drive well on a basically stock motor, then it'll drive really well on a much hotter motor like we tested it on. Now, horsepower-wise, my split one here didn't make quite as much horsepower as the longer runner, but that makes sense too. Remember, I'm only drawing off a half the carburetors and half the Plenum. As you get up in RPM, that's when you need that more Plenum, and I have cut it short. And that was actually one of the complaints about the Offenhauser intakes, is we got better about making heads and trying to go up in RPM. Everybody felt they fell short. And that's because that's not really what this was about. He was trying to make it work better with the lower flow stock heads of the time. You got to remember, it was early on. Today's heads flow way better, and that's why most people have forgotten about the Edelbrock, or not Edelbrock, but Offenhauser stuff, because the head flow has gotten so high that basically his intakes would have to be reworked to deal with the higher airflow. Otherwise, they're a restriction. And so a regular intake runs better than his do. But the basic idea really did work. Now, if you want a little more high RPM, one of the things, and again, this is an Offenhauser trick, is he would slightly notch, just like the Edelbrock Performer intake is, and get just a little bit of sharing. Now we're not talking a lot. We're talking like 3/8 of an inch down and maybe a couple inches wide. And you just slowly keep increasing that until your peak stops. And that gets you enough sharing between carburetors. Your other choice would be to try and increase the carburation a little bit. In this case, part of the reason the 12 pack did okay at high RPM is technically, if I need it, I have 1500 CFM worth of carburetor. And so what we saw was 502.5 at 5400 RPM. And compared to the Edelbrock, which was 502. So we made the same horsepower as the Edelbrock at just a few hundred RPM more, and I consider that a huge win for the way this intake is. Plus, I have the cool factor of 3 carburetors. I mean, you open the hood, somebody's going to go, wow, look at that. And so I feel like this was a really good fix for an intake that people had struggled with for so long. And the nice thing is it's a fairly simple fix. If you already have one of these intakes on the shelf, if you've tried to run it and you've had trouble, or you bought it from somebody else because they couldn't make it work, what you need to do is add a divider. And all I did was mill a slot in the end and add a plate in here. It's not welded. It's just thick enough that it won't move around. And then I milled down part of the plenum in order to reduce the volume. And this really works. It worked well with 2 quadrajets. It worked well with 3 Edelbrocks. It worked well with 2 Holleys. I was really very happy with how this behaved. And it would probably work well if you wanted to do, maybe even 4 Webers or 5 Webers. That would confuse somebody. It looked like a Lamborghini with too many stacks sticking up. But it has some versatility, and this really does work. So that's the boogeyman intake. Now, CAD company calls it the 1480. So if you look it up, he just did another run of these. This worked well enough, and people out there kind of got word when I showed what we were doing on the group that he sold out of that run that we had, 2 years ago with Richard that had shown up. So he just did another run, and he's got to get a machine. But this is very viable for some of you street rod guys and some of you that want something that's a way cool looking intake. And I will keep working on it. Like I said, we want to see if we can maybe make one fuel injected. But the dyno went down and he's got it up, but he is backlogged big time. So, hopefully in this next year, maybe as we get past February, we can get back to playing with some things, because unfortunately dyno has work to do. So anyway, that's the numbers. That's the boogeyman intake. This was Richard's better idea. You will see pictures of it out there if you look. I'm glad we finally got it to really run well. I'm glad that I got to verify that my 12-pack ran well, because I've had it built for a long time. And I wish you all luck in your projects and making things go. And we'll talk again at the next intake. So talk to you later. Bye.